Chapter 21, Problem 3. Which of the following is or are a structural isomer of 2-heptene? So we mentioned in problem number 1 that a structural isomer has the same chemical formula with different connectivities. Okay, so we also learned in problem number 1 that the number of hydrogens is related to the number of carbons and the number of pi bonds and the number of rings. So I'm going to jump to this next slide where we have this formula here. If you want to get the number of hydrogens, it's 2 times the number of carbons plus 2 plus the number of nitrogens, subtract the number of pi bonds times 2, the number of rings times 2, and the number of halogens. Okay, so in essence, we can do this problem without actually drawing out these structures. So I'm going to start off with the 2-heptene. So we know from the term hept that there's 7 carbons. And then ene tells us there's 1 double bond. So if we plug that into our formula, 2 times the number of carbons is 14, plus 2 is 16. We don't have any nitrogens, and I'm just going to tell you right now, there's no nitrogens in any of these structures or halogens. But we do have 1 pi bond because we have the ene or double bond. So we're going to subtract 2. So we're back down to 14. So we're looking for which ones have that chemical formula. Now, 3-heptene, I don't think you need to do the work to know that it should also have the same chemical formula, because the only difference between 2-heptene and 3-heptene is the location of the double bond. Part B, 2,4-dimethyl. So we have 2 1-carbon branches. So that's a total of 2 carbons. And then pent tells us that we have 5 more carbons. So that is also C7. And since it also has 1 carbon-carbon double bond, it should be the same number of hydrogens as the other ones. Part C, 3-methyl. So meth, 1 carbon, cyclohexene. So hex is 6 carbons. So we have 7 carbons, and we have a double bond, but we also have a ring. So we subtract 2 for the double bond, and we subtract 2 more for the ring. So this is actually H12. So this is definitely not the same as our 2-heptene. Part D, 1-methyl cyclohexane. So methyl, 1 carbon, hex, 6 carbons. So that's 7 carbons. But we have a ring. So if we look at the formula, a pi bond you subtract 2, and a ring you subtract 2. So 1 pi bond has the same effect as 1 ring. So it has the exact same formula as 2-heptene. E, 2-heptyne. So hept, 7 carbons. Yne means you have 1 carbon-carbon triple bond. So that's 2 pi bonds. So that's going to be C7H12. Now, these two would be structural isomers of each other. But they are not structural isomers of 2-heptene. Part F, 1,3-heptadiene. So instead of just ending in -ene, it's diene. So that means there's 2 carbon-carbon double bonds. So we have 7 carbons, but because we have 2 double bonds, that's 2 pi bonds. So that's going to also be H12. So that fits into another structural isomer of those ones. So the only ones that are structural isomers of 2-heptene are A, B, and D.